Unit 1 Study Guide, page 3. So this section is our analysis section. This is where you're given work, a problem that is already solved, and then you have to determine whether that the problem, the way that is solved, if it's correct or if it's incorrect. And if it's incorrect, you have to explain why or where the error is in the problem. So looking at the first one, it tells us to evaluate the square root of 28, right? So let's say a student had this problem and evaluated the square root of 28, right? Because your teachers don't make mistakes. So we have the square root of 28, and this student broke down the square root of 28 into 2 times 14, which is correct. 2 times 14 is 28. 2 we can't break down anymore, so we focus on the 14. 14 can be broken down into even number to 2 times 7. And again, 2 can't be broken down, and 7 is a prime number. It can't be broken down. So far, the student has done everything correctly. So now remember that we have to start looking for pairs, right? And we're only looking at the 2, 2, and the 7. So we do have a pair of 2's. Okay, now remember, when we have that pair of 2's under the radical, they join together and they come out as 1, right? They come out as that married couple. So whenever you have a pair of 2's underneath, it comes out as, my arrow went the wrong way. It comes out as 1, 2 out here outside of the radical. So we should have 1, 2 outside times the square root of whatever's left underneath, which is 7. And that is our answer. Okay, so this student, if we look at here, they got that they have one pair of 2's, but when they brought it outside of the radical, they brought both of the 2's out. You have to remember that they join together and they come out as 1. So both of these 2's, they come out as 1. Okay, so this student made the mistake of bringing 2 2's out of the radical. It should have only been 1 2. So that answer there is incorrect. Going on to the next one. It asks us to simplify, so we have 3 times x squared plus 1 plus 5x squared. Okay, so first thing the student did was distribute the 3, which is the correct move to do. So we have 3x squared plus 3 plus 5x squared. And then the final step is to collect like terms, which is correct. So this student did collect the 3x squared and the 5x squared. Right, so we're going to do the same, except, because we want to do the standard form, so we always have to start with the highest exponent first. So 5 plus 3 is 8. Okay, and now here's where the mistake was made. So when you're adding x squared plus x squared, it stays x squared. So remember, when you multiply like bases, you add the exponents, but here we did not multiply these two numbers, these two terms. We didn't multiply them, we combined them. So 3x squared plus 5x squared is 8x squared, and then we have that lonely 3. So our correct answer for this one should be 8x squared plus 3x. So what this student did was take the 3x squared plus 5x squared and went ahead and added the exponents, right? 2 plus 2 and got 4. But remember that we didn't multiply the bases here, so there was no reason to add the exponents. Okay, so correct answer, 8x squared plus 3. Okay, and the last one on this page, we have negative 1 plus I times negative 2 minus I. Okay, so it doesn't have the arrow here, but it looks like that this student, first thing they did was distribute the negative into the parenthesis, which is the correct thing to do. Right, so we're looking at this parenthesis first as a positive 1 out in front, so we can just rewrite this. So negative 1 plus I, and this student did the same thing, negative 1 plus I. Okay, now we distribute this negative, right? And that's a negative 1. So negative 1 times negative 2 is a positive 2. Right? The same thing here. They got positive 2. Okay, then we do negative times negative I. Right? Negative times negative is a positive, so that's plus I. Negative times a negative. That's where the student went wrong. They kept this a negative, so they forgot to distribute this negative 1 on the outside to that second term, to that negative I, which is where their problem came in. So now simplifying this out, we should get negative 1 plus 2, which is 1, and then I plus I, that's 1I plus 1I, which is a positive 2I, and that should be our correct answer. Okay, so this student was wrong because he forgot to distribute the negative to the second term in the second parenthesis. Right? He forgot to distribute the negative to the negative I. So that second I should be a positive I.